So today we're going to be using something called benchmark fractions to compare fractions. Benchmark fractions, you'll see the definition in our book. They are fractions that are really easy to visualize. The easiest one is 1/2. We know 1/2 means our whole has been broken into how many pieces or partitioned into how many pieces? Carla?
1.
We have one whole. If we are showing 1/2, that means our whole has been partitioned into how many pieces?
1/2.
Nope. Smith?
2 pieces.
2. Remember, the denominator tells you how many pieces has the whole been broken into or partitioned. 1/2 is the easiest fraction to use as a benchmark fraction. It's the easiest fraction to use to see, well, is this fraction smaller than 1/2 or is it bigger than 1/2? So what we're going to do first is you're going to draw a thin line, a thin straight line. So do your best to do a straight line that goes down through 1/2, 2/4, 3/6, 4/8, 5/10, and 6/12. Make sure you're going straight through all of those tick marks for 1/2, 2/4, 3/6, 4/8, 5/10, 6/12. But a thin line so that you can still see those fractions. Okay, is everybody good? Make sure, does your line go straight through the tick mark for 1/2, 2/4, 3/6, 4/8, 5/10, and 6/12. Now let's look at those fractions. 1/2, 2/4, 3/6, 4/8, 5/10, and 6/12. You don't have to write these. But what do you notice about all of these fractions? What do you notice about all of these fractions? 1/2, 2/4, 3/6, 4/8, 5/10, 6/12. Zari, what do you notice about all of these fractions?
All the denominators are even.
Okay. Anything else? Kingston?
All the numerators are half of the denominators.
Very good. So Kingston said all of the numerators are half of the denominators. What that means is if you divide the denominator by 2, you're going to get the numerator. 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. 8 divided by 2 is 4. 10 divided by 5 is 2. 10 divided by 2 is 5. 12 divided by 2 is 6. Another thing is, if you divide the denominator by the numerator, you get 2. 2 divided by 1 is 2. 4 divided by 2 is 2. The 6 divided by 3 is 2. 8 divided by 4 is 2. 10 divided by 5 is 2. 12 divided by 6 is 2. All of these fractions are equivalent to 1/2. That means when you're comparing fractions, think of what half of that number line with that denominator would be. So if you have 2/6 and you're comparing it to 5/8, there's 2 things you can do. First, we can use our number lines. We've already got our halfway mark listed. So using these number lines, we can see which one's greater, because if one is to the left of the halfway point and the other is to the right, well, that one on the left is smaller. Let's look at this. 2/6 compared to 5/8. So let's find our number line that's partitioned into 6 pieces. Here we go. And let's mark 2/6. Now, let's find our number line that's partitioned into 8 pieces. And let's mark 5/8. We see that 2/6 is to the left of our halfway point, and 5/8 is to the right of our halfway point. So, is 2/6 greater than, less than, or equal to 5/8? Lena? Less than. Because not only, so if we know, so let's think. Another way, say we didn't have a number line. You'll have a number line for everything today. But say we did not have a number line, or say we were working with a denominator that wasn't on here. We would think, okay, what would half be? So say we had we have these ones. What would our fraction that's equivalent to half look like with 24 as a denominator? This follows the same pattern. All of these are equivalent to half. The denominator divided by the numerator is 2. So, what would half look like with a denominator of 24? Cullen,
12.
what would the fraction look like?
12 24ths.
This is not equivalent to 12 24ths. So if 12 24ths is half, is 15 24ths greater than or less than half? Is it going to be on this side of 12 24ths or this side of 12 24ths? (15 24ths). Would it be on this side of 12 24ths or this side of 12 24ths? Left, right.
Right.
Right, because 15 is bigger than 12. So we know this would be to the right of the halfway mark. What would be an equivalent fraction to half with 16 as a denominator? It's following the same patterns. What is 1/2 of 16? 16 divided by 2 is what? Aaron? 8. So 8/16 is equivalent to 1/2 because 16 divided by 2 is 8. Just like 24 divided by 2 is 12, 12 divided by 2 is 6, 10 divided by 2 is 5, 8 divided by 2 is 4, 6 divided by 2 is 3, 4 divided by 2 is 2, and 2 divided by 2 is 1. Now, Aaron, where would 3/16 be? Would it be to the left of 8/16 or to the right of 3/16? To the left, because 3 is smaller than 8. So, look at where they would be on the number line. Is 15 24ths greater than, less than, or equal to 3/16? Please don't play. I don't know why that's open right now. We're not, if you're going to play with it, then you don't get to use it. Come on, guys. Look at where it would be. Think of what we had earlier. We saw that 2/6 was to the left of the halfway point. 5/8 was to the right of the halfway point. Number lines start with smaller numbers and end with larger numbers. So if 15 24ths is to the right of the halfway point and 3/16 is to the left, is 15 24ths greater than, less than, or equal to 3/16? Carla.
15 24 is greater than 3/16.
15 24ths is greater than 3/16. So when you're looking at these fractions, you can either use your number line or you can think, okay, what would half be with that same denominator? So basically you're thinking denominator divided by 2 is what? That's what half would be. Is this bigger or smaller, greater than or less than half? And then do the same thing with the other one. what would half with 16 as a denominator be? Okay, well 16 divided by 2 is 8, so 8/16 would be half. Is 3/16 bigger or smaller, greater than or less than 8/16? We're going to do a lot of practice with this. I'm unfortunately not going to be able to have this up and the math book, but now you know how to use it. You've got your halfway point, so leave that. Don't erase the halfway point, just erase the other points that you plotted. So go ahead and do that right now. Leave the line down the middle because you want to make sure. We're going to be comparing most of our fractions using 1/2 or 2/4 or 3/6 or 4/8 or 5/10 or 6/12. Yes, Carla.
2, 6. When we were trying to figure out is 2, 6 greater than, less than, or equal to 5, 8.
Mm-hmm.
I thought, what if we put down a line where 2, 6 is and 5?
Well, you don't have to do a line because you have your points, so you don't have to do a line. Your points tell you, your plots tell you where you are. 2/6 was to the left of the halfway point. 5/8 is to the right of a halfway point. Remember, number lines go from least to greatest, and you can write that. Because remember, number lines start with a smaller number and get bigger as you go. So that means if your point is to the left of your halfway mark, then it's smaller than a point that is to the right of the halfway mark. Zari, what's your question?
I was able to find something to put it in.
Oh, awesome. Excellent. And you can just leave it in there, and then you can, I don't think we'll have anything else this year that you'll need that for, but just in case, you can use that for other stuff. Really quick, let's come up with some more fractions that are equivalent to 1/2. Can we find a fraction that's equivalent to 1/2 if the denominator is odd? Like if we have a denominator of 15. Can we find a fraction that's equivalent to 1/2? Why? Why or why not? Zari?
We can't because odd number is an odd number is the opposite than even number.
Okay, what does that have to do with being able to find a fraction equivalent to 1/2? Carla?
The problem that we can't find it even probably is because that even numbers have 2 or more 2s.
Nope, you're about to confuse prime and composite with even and odd. Are all odd numbers prime? Nope. Cullen?
Because 2 is even, and you can't multiply odd numbers by 2.
I can multiply 15 times 2. 2 times 5 is 10. Regroup the 1. 2 times 1 is 2, plus 1 is 3. I can multiply odd numbers by 2. Smith?
You can't divide 15 by 2.
So why does that mean I can't find a fraction equivalent to 1/2 when my denominator is odd?
Because you'll probably end up with a remainder.
Okay? What even and odd means? Why can I not find a fraction equivalent to 1/2 when my denominator is odd? In order to find the fraction equivalent to 1/2, I divide the denominator by what? In order to find a fraction equivalent to 1/2, I divide the denominator by what? Michaela? 2. Can I divide an odd number by 2 and get an equal amount? No. Do any odd numbers have 2 as a factor? No. Has nothing to do with composite and prime, Carla. The problem is odd numbers do not have 2 as a factor. They may have other factors, but they do not have 2 as a factor. So if your denominator is odd, you cannot find a fraction equivalent to 1/2. There isn't one. Because if you divide an odd number by 2, you're going to get a remainder. And there's no such thing as 7 remainder 1/15. There's no such thing as that. So, if your denominator is odd, you cannot find a fraction equivalent to 1/2. But if it's even, you can. What would a fraction equivalent to 1/2 be with 14 as a denominator? Come on, guys. What do? Zadie, what do? I take my denominator and I
Divide it by 2.
to get my numerator. So, what's a fraction equivalent to 1/2 with 14 as a denominator? What am I going to do to 14?
Divide it by
14 divided by 2 is?
7.
So, what fraction is equivalent to 1/2 with 14 as a denominator?
7/14.
7/14. Carla?
We will multiply it by 2, and what we will get not multiply it, divide it by 2.
Okay, and what will our fraction be?
8/16.
Okay. Zari?
18 divided by 2.
Okay.
Ten.
20 divided by 2 is 10.
No, 19.
18 plus 1 is 19.
9.
9 what? That's not a fraction, that's a whole number.
9/18.
9/18. Colin?
20 divided by 2 equals 10/20.
20 divided by 2 doesn't equal 10/20. 20 divided by 2 equals 10. Just tell me, what's the fraction equivalent to 1/2?
10/20.
Smith?
11/20.
How do we say that? If it's this day of the month, we say it's the,
27.
so this would be 11 20 seconds. Carla?
It will be 12/24.
Now, these aren't basic facts, but we can follow a pattern. Because why not? Michaela?
13/26.
13/26. Aaron?
14/28.
14/28. We'll do, this will be the last one. Zari?
16/30.
Not 16/30. Colin?
15/30.
15/30. Notice how the numerator, we added 1 each time. The denominator, we added 2. The numerator, we added 1. That's a pattern. So if you add 2 to the denominator, then you'll add 1 to the numerator. Wait, until we get over here. See, we didn't do, I forgot one. I forgot 2/4, but that's okay. That's why. I just forgot 2/4 here. So every single time we added 2 to the denominator and 1 to the numerator. Okay, so now that we have these as a guide, let's go ahead and start the lesson. the main part of the lesson. Please read the sentences or the sentence under the title. Zari.
Benchmark fractions are common fractions such as 1/2 that are often used to compare or order fractions.
Good. So benchmark fractions are common fractions such as 1/2 and all of the fractions that are equivalent to 1/2 that are often used to compare and order fractions. So everybody, finger or pencil on example 1. We're on page 523, finger or pencil on example 1. Read in your head while I read out loud. A recipe for granola uses 5/8 of a cup of raisins and 1/6 of a cup of dried cranberries. Okay, so I'm imagining I'm making granola. I have my measuring cup. I need 5/8 of a cup of raisins and then 1/6 of a cup of dried cranberries. Okay? Is there a greater amount of raisins or cranberries? Now we know how to order fractions the math way. So now we're going to do it the quicker way, but it only works if we have number lines. Can we create our own number lines with fractions? No, because we may not get it perfect. And so that means two fractions may look equivalent, but they're not actually. Okay, don't know. So what we need to do is we need to figure out which of them is greater. Are raisins greater or are cranberries greater? There's 5/8 a cup of raisins and 1/6 a cup of cranberries. So we're comparing them to figure out which one's greater, which one's less. So we're going to use 1/2 as a benchmark fraction. We have our number lines here. We don't need our number line sheet for the example. So let's do our thin line. Write down 1/2. What fraction is equivalent to 1/2 with 8 as a denominator? Class?
4/8.
4/8. So our line needs to go through 1/2, 4/8, and what's the last one, class?
3/6.
Good. So let's draw our thin line through with your pencil through 1/2, 4/8, and 3/6. The fraction on the left is greater or less? Lena?
Less.
Less. The fraction on the right is
Greater.
greater. Okay. We know that 1/2 is equivalent to 4/8 and 3/6 because 8 divided by 2 is 4, 6 divided by 2 is 3. So now we just need to compare. Let's mark our raisins. So we're going to put a mark at 5/8 and let's label it with an R for raisins so that we don't forget later and accidentally write the wrong thing. And then let's label 1/6 for cranberries and let's label it with a C so that we don't get those mixed up. So we know we have 5/8 a cup of raisins, 1/6 of a cup of cranberries. So now we know, Lena told us the fractions to the left of the halfway point are less. The fractions to the right of the halfway mark are greater. So, since 5/8 is on the right and 1/6 is on the left, 5/8 is greater than 1/6. So there is a greater amount of raisins in the granola recipe. This is the most important thing to remember when you're using these number lines. If your fraction is to the left of the number line, it is less than half. If your fraction is to the right of the number line, it is greater than half. So use that halfway mark as a way to compare. If one is on this side and the other is on this side, then the one on the right is greater. Yes, Carla.
I think I remember a way instead of remembering that
Well, but that's what we're doing today.
Right?
That's what we're doing today. We're working with this today. There are, of course, other ways to compare. There's the way we learned the other day. But for today, we're working with this, okay? There are other ways to do this, but this is the way we're doing it today. Now, look at this question. Is there a greater amount of raisins or cranberries? Would 5/8 be the answer to, is there a greater amount of raisins or cranberries? If you asked me, do I need more raisins or cranberries? And I told you, oh, 5/8. Would that answer your question? Would you know which one to buy a bigger bag of at the store? No. Watch out, because some of these questions in these word problems will be asking for a fraction, but some of them will be asking for a word. Is this question, is there a greater amount of raisins or cranberries, asking for a number as your answer or a word as your answer? Carla?
Neither.
It's not asking for neither. What other option is there? Is there a greater amount of raisins or cranberries? Is it asking for a number or a word? Cullen?
A word.
A word. There's no other option other than numbers or words. Because the number would be 5/8 is greater. But that doesn't answer our question, is there a greater amount of raisins or cranberries? So if I'm going to the store, I don't know, do I need to buy a bigger bag of raisins or a bigger bag of cranberries? I need to know the word. Raisins or cranberries. In this case, raisins has the greater amount. Okay, let's look at number 2, example. Okay, so example 2, finger or pencil. Okay, read in your head while I read out loud. List 7/8, 1/2, and 1/3 in order from least to greatest. Is our answer going to be in numbers or words? Smith?
Number.
Numbers. Are there any words to even write?
No.
No. I'm not going to write the words least and greatest. This is not a real world problem, so I'm not figuring out are there more cranberries or raisins. This answer will be listed in numbers, or will be written in numbers. So please pay attention to that, because if the question is asking for a word and you put a number, well, that doesn't answer the question. If the question is asking for a number, like how many books are on the shelf, and you just put books, does that answer the question? No. If the question asks, are there more books or DVDs, and you put 5/8, does that answer the question? So watch out. Is the question asking for a word or a number? Luckily, this isn't even a real world problem, so we don't even have to worry about it. We're going to use 1/2 as a benchmark fraction to put these fractions in order. So again, we have a number line partitioned into 2, a number line partitioned into 8, and a number line partitioned into 6. What fractions show 1/2? What fractions show 1/2? Zari.
1/2, 4/8, and 3/6.
1/2, so I'm going to do my thin line through 1/2, 4/8, and 3/6. Try to make it straight. My hand was in the way of the, so I couldn't see. But try to make it as straight as you can. So my hand was in the way of the projection, so I couldn't see where I was. But you don't have that problem. So now we made our 1/2 mark. We know 1/2 is equivalent to 4/8 and 3/6, so we made our 1/2 mark. Now we're looking for where these fractions fall. So let's plot them. 7/8 first. I'm going to go to the number line partitioned into 8 and put my point at 7/8. I don't need to label that because do those numbers represent anything like cranberries or raisins? No, so I don't need to label it. Then 1/2, well, that's right on my halfway mark. And then 1/3. Uh-oh. I don't have any fraction. I don't have a number line partitioned into 3. But I do have a number line partitioned into 6. And we can find a fraction that is equivalent to 1/3 with 6 as a denominator. What did I do to 3 to get 6? Zadie.
Multiply by 2.
Multiplied by 2. Whatever I do to the denominator, I also do to the,
Numerator.
so 1 times 2 is,
2.
so that means 1/3 is equivalent to,
2 6.
so I can come over here and plot 2 6. So sometimes in this lesson, you may need to find an equivalent fraction. But remember, all you do is you look for a number line that has a multiple or a factor of that number, and then you multiply or divide to figure out what the numerator would be. So now we just have to put them in order from least to greatest. Remember, the fractions on the left are smaller than half. The fractions on the right are greater than half. So let's look. Which fraction is furthest to the left? Michaela?
2 6.
2 6. But do we have 2 6 up here?
No.
But we know 2 6 is equivalent to,
1/3.
so what's our least fraction?
1/3.
1/3. And then if we keep going to the right, what fraction comes next? Lena?
1/2.
1/2. That was in our original problem, so do we have to change it?
No.
Nope. And then the greatest fraction, the fraction closest to the right, is, Cullen?
7
7/8. Do we have to change that?
8. No.
No. So don't forget, if you do have to find an equivalent fraction, when you're writing your answer, make sure you write it the way it was given in the problem. Okay, so is everybody with me? You can use your own number line to do this, which may mean you may not have to find as many equivalents because you have a lot more options. However, there's a chance that you might have to find some equivalent fractions, but remember, all you're doing is you're picking a denominator that you have that is either a multiple or a factor of the one you're given, just figuring out what you have to multiply by or occasionally divide by, and doing the same thing to the denominator, the numerator. Yes?
We just flip-flop the numbers.
What do you mean we flip-flop? Oh, yep, that is true. We did. So up here, they're written how, Cullen?
From greatest to least.
Very good. So Cullen noticed that we just flip-flop the numbers, which means in the original problem, they are given us in order from greatest to least. That's just a coincidence. That won't happen every time. So don't expect that and just be like, I don't have to show work because I know it's just going to be flip-flopped. That's not true. Okay, let's look at the guided practice. Helper number 1, please sanitize, erase. Okay, so the guided practice says, use a benchmark fraction to compare, period. Write greater than, less than, or equal to. So number 1, we have 3/4 and 1/2. Well, we don't have a number line, so let's go to our other sheet. You guys already have this, but I'll go ahead and draw my halfway mark. Through 1/2, 2/4, 3/6, 4/8, 5/10, and 6/12. All of my fractions that are equivalent to 1/2. And number 1 is 3/4 greater than, less than, or equal to 1/2. Cullen, bring your expo marker. Plot 3/4 and 1/2. Oh, right on where they meet, where the lines meet. So like right where they meet. And 1/2. Can you reach it? Oh, where they meet. Guys, remember you're putting the plot right where they meet. Like where the T is, or sometimes it's a cross if the tick mark goes all the way through. Okay, so Cullen plotted 3/4 and 1/2. Which of these fractions is further to the left?
1/2.
1/2. So that means if 1/2 is further to the left, then is 3/4 greater than, less than, or equal to 1/2?
It is greater.
It's greater than. 3/4, whatever fraction is further to the right is greater than the fraction that's further to the left. Okay, is everybody with me? When you erase, remember to put your line for the halfway mark back. you have to. Sometimes you won't have to. Number 2, 3/6 and 3/4. That's me. Victoria's not in here. Lena, bring your expo marker and plot 3/6 and 3/4 so that we can figure out is 3/6 greater than, less than, or equal to 3/4. So first plot 3/6. Oh, you have a 2, so make as big a circle. Here, use this one. Since yours is just very small. So first plot 3/6. And now plot 3/4. Okay, thank you. So Lena, which one's further to the left? 3/6. Which means, is 3/6 greater than, less than, or equal to 3/4?
Less than.
Less than. Very good. Is everybody with me? Okay, if you are ready, well, everybody, let's look at what we're doing. Can I use this?
Yeah.
Because I forgot to get my math book out. No, I'll just be quicker. Numbers 3 and 4, you already have a number line for you, so you can use that. Numbers 5 through 10, you are comparing two fractions. You may use your benchmark fractions sheet, or I'm sorry, your fraction number line sheet. Numbers 11 through 13, you are ordering, so that means you have 3 fractions. You may again use your fraction number lines. But remember, you're putting them in order. Pay attention. Make sure if you have to change one to an equivalent fraction, make sure on the answer line you put the fraction you're given. You may not have to because luckily you have a lot more options. On the back, 14 through 16 are word problems. They are just like number 1. You are comparing fractions, so pay attention. Is the question asking for a number or a word? Number 14, a recipe calls for 1/2 a teaspoon of salt and 1/4 a teaspoon of baking soda. Which fraction is greater? Is that question asking for a number, either 1/2 or 1/4? Or is it asking for a word, either salt or baking soda? Zari.
It's asking for a fraction.
So what does that mean, number or word?
A number.
A number, very good, because it says which fraction is greater. So that means it's asking for a number. If it says, does she need more salt or baking soda? It would be asking for a word, because you would need to put salt or baking soda. So pay attention. Is it asking for a number or a word? Numbers 17 and 18 are critical thinking with numbers. Number 19 is critical thinking with words. You do have printed homework, however, and I have it over there. It's the same setup. Numbers 1 through 3, you're comparing. Use your benchmark fraction or your fraction number lines. Numbers 4 and 5, you are also comparing, but they already gave you. Carla, you're not drawing with that right now, otherwise you lose it. I don't even know why you have that in your hand or why it's open. It's just drawing out there, and I'm not giving you another one. So numbers 4 and 5, you're comparing fractions. You already have number lines there. Numbers 6 and 7, you're comparing. You don't have, so you can use this. Numbers 8 and 9, you're putting them in order. Just like example 2, use your fraction number lines. Number 10 and 11 are word problems. Figure out, are you ordering or are you comparing? Ordering means you have more than 2. Comparing means you just have 2. And are they asking for a number or a word as your answer? Number 12 is vocab. Number 13 is multiple choice. Make sure you use this. I cannot force you when you were at home. However, I will be able to tell if you used it or not because you will have lots of silly answers if you did not. Okay. If you are ready, go ahead. If you need a little more practice, I will do a couple of the independent practice with you. Would anybody like to help me with number 5? Kingston? Okay. Number 5, we have 1/3 and 8/10. So come bring your expo marker. If you want to keep going, Keep going. Make sure when you have a number line on your math book that you plot the points. I need to see them, or on your math homework. So first we're going to plot 1/3. And now plot 8/10. Okay, thank you. Back to your seat. Careful. Go ahead. So Kingston, which one is further to the left? 1/3 or 8/10? 1/3. So that means 1/3. Is it greater than, less than, or equal to 8/10? Less than. Okay, very good. Who would like to help me? Would anybody like to help me with number 11? Carla, I saw your hand first. We have 1/2, 1/8, and 3/4, and we're ordering them from least to greatest. So come up here. Bring your expo marker. And plot 1/2, 1/8, and 3/4. Okay, that's okay. I think you would have been okay though, because that should be the only one that you have to do. Okay. Don't push it all the way, because then you're putting more weight here, and it will tip. Bigger than that, that just looks like part of the line. Make sure when you're plotting points that you're making big dots, but not crazy dots. Okay, go ahead and go back to your seat. Okay, Carla. So now we need to order them from least to greatest. So are we going to start on the left to find the least, or are we going to start on the right to find the least?
The left.
The left. So which one comes first? If we're going from left to right,
We will start with 1/8.
1/8. And we're going to start moving to the right. What comes next?
1/2.
1/2. And then the fraction that's furthest to the right.
3/4.
Okay. Make sure you put commas between your fractions when you're ordering them. Any questions? Everybody feel good about it? Go ahead, use your tools. Don't ignore them because you want to rush through.